In this video, I introduce a variational autoencoder. A vanilla autoencoder is an encoder-decoder machine learning architecture, which is used for reconstruction or representation learning, as shown here. This encoder, this decoder, this input, and this latent representation, and this is the reconstruction. The reconstruction loss is defined as L, where X is input, alpha set is encoder, G phi is decoder. The representation Z in the latent space is achieved at the minimum loss. Autoencoder is trained on a dataset from X1 to Xn by minimizing the least square error as shown here. Autoencoder faces challenges when used as a generative model, since the latent space contains only a small amount of information for new output generation. Variational autoencoders constrain the latent space of an autoencoder so that it contains sufficient information to generate the desired outputs. A simple way is to construct the latent space is to have the encoder output a mean and a standard deviation of Gaussian distribution for each latent dimension, as I shown here. As input, the output from encoder is a mean and a standard deviation. Instead of a single latent vector, however, this architecture is not trainable due to the fixed mean and deviation. Reparameterization trick is used to solve this issue by modifying the latent variable z, where e is a random noise variable. We sample a random variable e and then treat the sampling of z as a deterministic process. During training, the encoder maps the input x to the posterior q, and then minimize the k-error divergence between q and p, as shown here. The reconstruction loss is defined as a negative log likelihood, as shown here. In practice, the mean squared error between the mean of the output p and the input x is defined as a reconstruction loss. The log probability is computed by using this formulation, dropping off the constants, this one, the reconstruction is rewritten as ESE, as shown here. To use VAE as a generative model, we first sample Z from the prior P, which is used as input to the decoder to generate the likelihood P. Minimizing the total loss in VAE becomes to maximize the evidence lower band, as shown here. Here shows the several cases, the encoder and the decoder in the variational autoencoders. For more details, please check with these references. Thank you.